Hello Pre-Calc BC! So tonight you are watching a video on the first day of our Chapter 4 notes. This is going to be, for the most part, a little review from last year, and we are going to discuss composite functions. Composite functions are functions where one function becomes the input of the other. So we're used to this notation, f of g of x, from last year. Today we're going to start using this notation here. They mean the exact same thing. Okay, so just when you see these in the future in your book, they are the same. So alright, we've got f of x is 3x plus 2, and g of x is x squared plus 3. This is the same as saying f of 1. So remember, you're always going to evaluate the inside part first. And f of 1 is when we plug a 1 in for x in f of x, which gives us 5. And now we are doing f of 5. So now, of course, we take 3x plus 2 and we're plugging in a 5 instead of a 1 like we were before. And that is 17. Alright, we'll try this again. This is f of g of 1 that you know from last year. So we are evaluating g of 1 first. Make sure you use the right function. We're using g of x now. And plug in your 1 for x. And you should get a 4. And now we're doing f of that value, so f of 4. And again, make sure you go back to the f of x function. So you should get a 14 as your final answer. Alright, and we'll do one more like this. G of f of 0. And again, we'll do f of 0 first. 3 times 0 plus 2 is just 2. And then we're doing g of 2. 2 squared plus 3, so 7. Alright, so that should be a little review from last year. Now let's take a look at a graph and see if we can identify some values. So find the following from the graph below. You have f of x and you have g of x. So this is something I don't think we really did as much last year. So first, start off by finding the inside part, f of 1. Okay, so when x is 1, f of 1, your y value is 5, but now we're finding g of 5. So you're going to where x is 5 for your g function, and your y value is -3. So this is your final answer. Alright, let's try that again. G of f of 2. Alright, so f of 2, 2 is your x value. Go to 2 is your x value on f of x. F of 2 is 4. So now we're finding g of 4. So now that 4 switches back to an x value. G of 4, and that is -4. Okay. Alright. F of 3. So again, 3 is an x value. That's here. F of 3 is just 3. So now we're finding g of 3. G of 3 is -5. And f of 4. 4 is an x value. F of 4 is also 4. So we're finding g of 4. So now 4 is an x value again. And when x is 4, g of 4 is -4. Okay, moving on. In composite functions, the domain is restricted by the domain of the input function. So you talked about this last year when you were concerned about domain for composite functions. You said whatever one you're plugging in, that's the one whose domain you care about. Okay, so for example, f of x, 1 over x plus 3. We know that x can't be -3. and g of x, negative 2 over x, we know x can't be 0. So now we are finding f of g of x. G of x is your input, so that's the domain that we care about. We're looking at this right now. X can't be 0. Okay, so we are taking negative 2 over x, and we are plugging it in place of x in f of x. Alright, so 1 over, instead of x, I'm putting negative 2 over x plus 3. And then it's going to help me to figure out the domain if I simplify this further. So I'm going to get a common denominator on the bottom by multiplying by x over x. So that's 1 over negative 2 plus 3x over x. And then I'm just going to go a little further with this. I'm going to multiply by the reciprocal. So that's going to be 1 times the reciprocal x over, I'm just going to rewrite that as 3x minus 2. And that's just x over 3x minus 2. Alright, so now we're going to do our domain. So what I always told my kids last year is that you go with the most restrictive, okay, the most restrictive domain. So if you look, we already knew x can't be 0 because that was our input function. X can't be 0 because if this is a 0 here, then the entire thing is undefined. So, alright, you still can't have x be equal to 0. You can see that here as well. However, when you do the reciprocal, you suddenly have a new denominator. So now, x also can't be another value. 3x minus 2 equals 0. Solve for x. X can also not be 2/3. Okay, so it's both of those values cannot be x. Alright, let's do g of f of x now. Alright, so for this one, your input function is f of x. So that's the domain we care about now. X can't be negative 3. And we have negative 2 over, and instead of x, we're writing that whole thing 1 over x plus 3. And then it always helps me to simplify further so I can figure out the domain. So I'm going to multiply by the reciprocal. And then you can distribute that if you want, or you can just leave it. F of x. Alright, so technically, I just gave you this function, negative 2x minus 6, or negative 2 times the quantity be x plus 3, we wouldn't say that this has a restriction. It would just be all real numbers. But remember, originally, you had x plus 3 in the denominator. So this means that the domain is still x such that x can't be negative 3, okay, which was our original f of x domain up here. So that would be our domain. Alright, let's try it with a little harder functions. F of x equals x squared plus 4. This would be all real numbers. That's parabola. G of x equals root x minus 2. Okay, when we have a square root, we know that what's underneath the square root has to be greater than or equal to 0. So x has to be greater than or equal to 2 for that one. Alright, we're finding f of g of x. That means that g of x is the input. Okay, so that's going to look like this. We're plugging in g of x in place of x in f of x, and then we'll simplify. Square and square root cancels, and combine like terms, and you should get an x plus 2. Okay, but remember our domain is based on the value or the domain of the input. The input was g of x, so this domain x is greater than or equal to 2 still has to apply, otherwise you have a negative underneath your root here. So this is still our domain. Alright, one more like this and then some different stuff. Okay, f of x, our domain, we can't have a denominator of 0, so x cannot be negative 2. And then g of x, same thing. We can't have a denominator of 0, so x cannot be 1. We're doing f of g of x. That means that g of x is our input function. So right now we're looking at that as our domain. I'm taking 1 over, and g of x is replacing x. And just like we did on a problem before, let's get a common denominator in the bottom. It's going to be easier to simplify. Let's show a little more work this time. Okay, so then we're going to have 4 plus 2x minus 2 all over x minus 1. I'm going to keep on going. 2x plus 2 over x minus 1. And then we're going to multiply by the reciprocal. Basically, that's going to flip our fraction. So you should end up with an x minus 1 over 2x plus 2. And that's f of g of x. Alright, original domain was x can't be 1. That is true all through here. Okay, however, when we do our reciprocal, we have a new denominator. Now 2x plus 2 can also not be equal to 0. So you're going to see that x can also not be equal to negative 1. So you do need to include both of those values. So x such that x is not equal to plus or minus 1. Alright, so number 6, show that f of g of x is equal to g of f of x and that they are both equal to x. We used this last year to show that two functions were inverses. So when you do this, you want to show all of your work step by step so that I can follow it. So f of g of x, let's start with that one. We are taking g of x, we are plugging it in place of x. So do that first. And even though a bunch of stuff is going to cancel, just one step at a time. So I'll distribute x minus 1 plus 1, and then these combine and I get x. And then we'll do the same with g of f of x. Only this time, f of x is the input function. So 2, this guy's going here now. And again, step by step, please. So we'll distribute 1x plus 2 minus 2 combine equals x. And so what we'll get into later is that means that these two functions are inverses of each other, which is where x and y are switched. Alright, last thing. Given composite function h of x, find a possible f of x and g of x. So this one you can make it as hard or as simple as you'd like. I prefer to make it more simple. So one thing that you can do is usually there is something that looks pretty obvious that it's been plugged in. So like basically what we're being given is this, the plugged in step, and what you have to say is what the original f of x and g of x were. So here what had been plugged in was the 2x minus 2. Usually that's what's in parentheses. So like x squared plus 4, this is what has been plugged in. Okay, so it's up to you whether you want to make that part f of x or g of x. It doesn't matter. I'll just make it f of x. So the plugged in part is x squared plus 4. That's the plugged in part. That means I'm finding g of f of x. Okay, because f of x was getting plugged in. So then that means that what was there originally was a 3x squared plus 1, because this went in for x there. So g of x has to be a 3x squared plus 1. Okay, and then just try it. If you did g of f of x, you would take 3, and then you would plug this in. X squared plus 4 squared plus 1. And yes, that's what you have. Okay, so this is all they're looking for. Okay. Again, usually what's being plugged in, what's in parentheses, you can make that your g of x or f of x. So this time I'll do f of g of x, just to switch it up. So g of x is the one that's getting plugged in. So what got plugged in was x minus 6, x squared plus 4. And then remember, originally that whole thing was just an x. That means f of x has to be 17x plus 7. Okay, because then when you take this and plug it in for x, you're going to get that. All right. Okay, there you go. We will talk about this tomorrow. We will have plenty of time to do so. This just allows us to have a work day on the day I will be gone next week. So good luck on your homework, and make sure you have questions for me tomorrow so we can go through them. Have a great night.